Question number 3, example number 3. If ax plus by upon x plus y is equal to bx plus az upon x plus z is equal to ay plus bz upon y plus z, then and x plus y plus z is not equal to 0, then show that a plus b upon 2. This is our 2 proof. Show that finally a plus b upon 2. Now first we write this. Let ax plus by upon x plus y is equal to bx plus az upon x plus z is equal to ay plus bz upon y plus z is equal to k. K means each ratio. K means each ratio. Then we write here, therefore by theorem on equal ratios, by theorem on equal ratios, theorem on equal ratios, we add numerators at numerator and denominators at denominators. Therefore, see here, see this carefully. Ax plus by plus bx plus az plus ay plus bz upon denominators at denominator x plus y plus x plus z plus y plus z is equal to k. K means each ratio. Each ratio. Now see this. We take this ax plus ay plus az because a is common here. Okay, so we take these three together. Then remaining bx plus by plus bz upon x plus x 2x plus y plus y 2y plus z plus z 2z is equal to k, each ratio. Now here at numerator, see this, at numerator here a common, we take a common. What is left? X plus y plus z plus b common here, b in bracket x plus y plus z upon denominator 2 common and bracket x plus y plus z is equal to k. Did you understand? Therefore here x plus y plus z common. Okay, see this, x plus y plus z common. What is left? A plus b, that is left upon here 2 in bracket x plus y plus z is equal to k. Now here this bracket and bracket cancel. Therefore a plus b upon 2 is equal to k. This is our 2 proof. This is our 2 proof. Show that a plus b upon 2.